Hi, in this video we'll be talking about measures of dispersions. Okay, so dispersions is a big word and what it means is pretty simple. We are just talking about how spread out are the data. Okay, in the previous video we have learned about central tendency, where we discussed about mode, median, and mean, right? So now we are going to focus on other parts, except other parts of the data. We're not just going to be looking at the middle section, right? We'll be looking at how spread out are the data, okay? So when we talk about measures of dispersion, or how spread out are the data, we'll be talking about two things. Okay, two things. The first one is range, and the second one is your quartiles. Now we'll be talking about that later on, but for now, when we are describing data to people, we should always have one measure of central tendency and one of the dispersion. Okay. So just to kind of give you guys an idea of why do we need to know about the dispersion, let's take a look at these two examples. So the first set of data, I have 5 samples, right? -10, 0, 10, 20, 30. Okay, and the second set of data is 8, 9, 10, 11, and 12. Now, with the first set of data, if I were to find the mean, right, we use this mu, right, this symbol to represent mean. So the mean for the first set would be the sum of all of them, right? So -10 plus 0, 10, 20 plus 30, the sum of that divided by 5. So because here I have 5 samples here, so my mean in this case would be 10. Now, for my second set of data, if I were to find the mean, it would be 8 plus 9 plus 10 plus 11 plus 12. That's the sum of the 5 samples divided by 5, which also gives us a mean of 10. Right? So in both sets, my mean is 10 for each of them. However, if you look at the dispersion of each set, right, the dispersion of the data in each set, you can clearly see that my first set, which starts from -10 all the way up to 30, right? My first set of data is a lot more spread out, right? Yes, it's a lot more spread out than the second set. So 8, 9, 10, 11, 12. It's pretty much very close to each other, right? It's not as spread out as my first set of data. Okay, so in this video we'll be talking about how spread out, right? How spread out are the data. Okay. So as I mentioned just now, when we talk about dispersions, we're talking about range and quartiles. Let's start with range first. Range is very simple. It's just a maximum value minus a minimum. Okay. So with the examples that we talked about just now, the range for the first set, right, the range is 40, and the range for the second set of data, the range is 4. Okay. So of course, the bigger the range, the more spread out your data is. However, because when we talk about range, we're only talking about the maximum and the minimum. We don't really know what happens in between, right? So in order for us to know, to have a better big picture of the data, we're going to be looking at the quartiles. Okay, the quartiles. Okay, so when we talk about quartiles, we need to start off by reviewing on our medians. So we already talked about medians in the previous video. The median value cut my data into halves, lower half and upper half, right? So median is something that we know already. Quartiles are basically the medians of the lower half and the medians of your upper half, okay? So the second quartile, I'm going to begin by skipping to the second quartile. The second quartile is your median, okay? So which means your 50 percentile of your data, right? So as we mentioned just now, median cuts my data into half, right? So and that n plus 1 over 2, that is sort of the formula that helps us to find where my median is, right? So now that, let's say today, assuming that we know where my median is, I can find my first quartile. My first quartile is the median of the lower half. Okay, the median of the lower half is my Q1, my first quartile. It is also known as the 25th percentile, right? 25th percentile. So similarly, if I switch to the upper half of the data, that would be the median of the upper half of the data would be my Q3, my third quartile. Okay, also known as the 75th percentile. Okay, a new term, interquartile range, or IQR. My interquartile range, my IQR, is simply my Q3, my third quartile minus my first quartile, right? Q3 minus Q1. All of this may seem complicated, but let's take a look at some examples. Okay. Okay. So the first one, I have 3, 4, 4, 5, 6, 8, 8. Okay. So I have a total of 1, 2, 3, 4, 5, 6, 7. I have a total of 7 samples here, right? So if I use the formula, my n will be 7. 7 plus 1 over 2, that gives me 4, right? So in this case, I have seven samples, and the fourth one will be my median. So that's my Q2, or just median. Okay. Now my median cuts my data into the lower half and the upper half, right? So to find Q1, I'm going to find the median of my lower half. So my lower half consists of 3, 4, and 4. And the Q1 is the median of the lower half. So this 4 right here, that is my Q1. Okay? To find Q3, Q3 is the median of the upper half, right? Q3 is the median of the upper half. So I have upper half is 6, 8, 8. So my Q3 will be this 8 there. Okay? So again, we started by finding what's my median. My median cuts my data into lower half, upper half. To find Q1, I find the median of the lower half. To find Q3, I find the median of my upper half. Okay? Let's take a look at another example. Alright, so now I have a lot more data here. So I have 62, 63, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here I have 10 samples, right? 10 samples. So my n in this case will be 10. Right? So as we discussed in our earlier videos, when I have even number of samples, to find the median, we need to go through a bit more work, right? So my median is going to be between, so 10 plus 1 over 2, that gives me 5.5, which means my median will happen between my 5th term and my 6th term. My 5th term is 70, my 6th term is 72, so 70 plus 72 divided by 2, that gives us my median is equal to 71. Okay? If you're not sure how they got this 71, please watch the previous video. So if my median is 71, then this 62, 63, 64, 64, 70, that would be the lower half. 72, 76, 77, 81, 81, that would be the upper half. So to find my lower quartile, or to find my first quartile, right? So some people say lower quartile, some people say first quartile. They mean the same thing. So my Q1 would be the median of my lower half. So in this case, it would be 64. To find Q3, third quartile or upper quartile, I'm going to find the median of my upper half. The median of my upper half, in this case, it will be 77. Alright? And the interquartile range is just Q3 minus Q1. So my Q3 is 77, Q1 is 64, so my interquartile range in this case is 13. Okay? So let's go back to the first example. If I were to find the interquartile range, I'll take this 8 minus the 4. So the interquartile range for the first example will be 8 minus 4, which is 4. Alright? Now, a little bit more on quartiles. Quartiles are also useful when we're trying to determine if a data is considered as outlier, right? So outlier means some extreme data. When we are collecting data, sometimes there will be some exceptions, right? Either way too big or way too small. But how do we know if they are actually outliers or not? So we will have to refer back to our quartiles, okay? So we would consider a data or any data to be an outlier if it is at least 1.5 times of your IQR, right? 1.5 times of your interquartile range, okay? Above Q3 or below Q1. Okay, so let's take a look at an example. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 samples here, right? So, and it is this 16 that looks odd because it is a lot bigger than everything else, but we don't know if it's an outlier or not. So let's try to do some math here. So first, they want us to find the first quartile, median, third quartile, and the IQR, right? So to find the median, let's find the median first, right? Let's find the median first. So here I have 10 values. The median is going to be between the 5 and the 6, right? The fifth term and the sixth term. So take the mean of them. I will get 5.5. The median is 5.5. And now this is my lower half, and this is my upper half. Q1 is just the median of the lower half, so that's your 3. My Q1 is 3. And my Q3 is the median of the upper half, so my Q3 is 7. Okay, so my interquartile range is my Q3 minus Q1, so 7 minus 3 gives me 4. Alright? Okay, so the last part. Is 16 an outlier? Right? Now, 16 is closer to my Q3, so I'm going to use Q3 to help me out. So my Q3 plus 1.5 times my IQR. My Q3 is 7, right? Q3 is 7. My IQR is equal to 4. So 7 plus 1.5 times 4 gives us 13. So anything that is more than 13 is considered as an outlier. Therefore, 16 is an outlier. If they give us something, for example, negative 10, right? Negative 10 will be on this side. So in that case, I would use Q1 to help me, to determine if negative 10 is an outlier. Now, the last part of this video will be about box and whisker plot. We learned about this when we were kids. And so for a box and whisker plot, the left hand side will be minimum, Q1, Q2, Q3, and the maximum. So in this case, my box and whisker plot will be this. Alright, I hope you guys find this video helpful, and I'll see you guys in the next video.